So hello and welcome to the channel. In today's video we are going to discuss the applications of DC to DC buck and boost converter, and this is the first video of the DC to DC buck boost converter series. And after this video we are going to see the working and analysis of the circuit. We will see the simulation and we will see the closed loop simulation in the MATLAB itself. So this series is going to be very much exciting and you will get so many things to learn in this series. So let's start today's video and see the applications. See why I am keeping my first video as an application of this circuit, because if you don't see the application you will not get an idea that why you are learning this series, because that becomes most important part whenever you are learning anything new. So that is why DC to DC buck boost converter. So the first application that comes into the picture, that is the solar PV system. Now if you see solar PV panels, the input for the PV panels is the solar irradiance and the temperature. Now this solar irradiance and temperature, that totally depends on the weather, right? So depending on the weather conditions we will get the output. Now these panels are generating the DC voltage, so as the weather is variable, the output DC voltage would also be variable, right? But at the output we need fixed DC voltage, and that is where your DC to DC buck or boost converter will come into the picture. Now when I am talking about the buck converter, that means it is stepping down the DC voltage. When I am talking about the boost converter, that means it is stepping up the DC voltage. So you need to understand that depending on the PV rating, depending on the load conditions, we can use either buck converter or the boost converter. So the idea is clear. First there will be a PV panel, then there would be a DC to DC converter. Then after that we will be having the DC to AC converter that will convert the fixed DC voltage into the controllable AC voltage, and then the AC voltage will be fed to the particular load that is connected at the output of the inverter. So that is the basics of the solar PV system. In the future days I will come up with a brand new series of the grid connection of the solar PV system. In that also you will get a lot many things to learn. But for now let us keep our video till this point only. The second application is also for the renewable energy sources. The second widely used renewable energy source is the wind energy system. In the wind energy system also we are getting the variable AC at the output of the wind turbines. Now this variable AC needs to be fixed. Hence what we will do, we will connect a rectifier. If you have seen the video for the applications of the rectifier, you will get an idea that how this rectifier is used in the wind energy system. So the rectifier will convert the variable AC into the variable DC, and after that we will have the DC to DC converter that will convert the variable DC into the fixed DC, and afterwards we will be having an inverter that will convert the fixed DC into the variable AC, and then we will connect our load. Now as you see in the renewable energy sources we are using so many power electronic converters, and with the help of the power electronic converters we are able to harvest the energy that is available around us. Hence we can say that the advancement in the power electronics has opened the doors for the renewable energy sources, and the renewable energy sources will become the future for the energy sector, and it is rapidly growing energy sector, and you will see so many companies investing in the solar and wind applications. Now let us talk about the third application of the DC to DC buck and boost converter, that is in the automobile sector. In the automobile, maybe it's two-wheeler, four-wheeler, six-wheeler, we are having so many electrical loads installed in the automobile. So in order to run these loads we need to use batteries. Now these batteries, at its fully charged there will be some voltage. When the battery is getting discharged the voltage will become lower. Hence we can say that over the time the battery voltage is variable. Now to run this load we need the fixed voltage. So at that time this DC to DC buck or boost converter will be used. Now you know what is buck converter, you know what is boost converter. You need to understand whole rating of the load and the battery, and depending on the situation you can use either the buck converter or the boost converter. It's totally depending on you. The fourth application is also based on the automobile sector only. See in the charging system, see every battery operated vehicle needs to be charged, and most of the vehicles are getting charged with the help of the alternator. So alternator is basically connected to the prime mover. The prime mover is feeding energy to the alternator. Alternator is generating the variable AC. Now this variable AC is converted to the DC with the help of the rectifier, and as it is generating the variable DC we need to make it fixed, right? Hence we are using the DC to DC converters which will fix the variable DC that is generated at the terminals of the rectifiers. So these are the important applications of DC to DC converter. If you see the renewable energy sources, the importance of RES is huge. If you see the automobile sector, we are using it everywhere. Now the fifth and the final application is in the electronic sector. In the electronic sector, when we are using any DC components as any DC loads. At that time, some of the components may need 5 volts, some of the components may need 12 volts, some of the components may need 9 volts. Depending on the application, we need the amount of DC sources, and that is why in the electronic sector the DC to DC converters are usually recommended and are usually used. And this is the whole packed applications for the DC to DC converter. I hope after hearing all these applications you guys are really excited. I'm also excited. We are going to explore this DC to DC converter into future videos. These videos are going to be longer. You will get the cut to clear idea that how this converter is made up, why this circuit component is there, what is its use and the purpose. So there are a lot of things coming up to the channel, so I highly recommend you to subscribe the channel and share the video. So at the end, thank you very much guys for supporting the channel and watching the video. Thank you very much.